Maybe it's way off for sure.
All right, so today what we're going to be doing is problems 1, 2, and 6. Then you need to do all the remaining problems, show me that you've completed it, and I'll get you points in the grade book. Okay, don't forget about section 3 homework is due tonight.
Can I go run and get a pencil?
Or you want this online?
Sure, I'll use it anyway.
Yeah. All right, so here we go. Problem number 1. So obviously the above table is in your worksheet, but it says use the above table to determine how much heat is released when 1 mole of gaseous methanol condenses to a liquid. Okay, so first things first, just like we've done in previous problems here, what we're going to do is we are going to write down exactly the numbers that are given. So in this scenario here, the only thing that's given is 1 mole of gaseous methanol. So I'm going to write down 1.00 mole, and methanol, I'm going to use the actual formula I have it written here, CH3OH. So I'm going to say 1 mole CH3OH. Then I'm going to say times, I'm going to draw the line. What unit has to cancel diagonal? Moles of CH3OH. Now, I'm going to leave the top blank for right now, and I'm going to talk about this heat business. So, number 1, we're dealing with methanol. The second thing, we have to think through what happens. So, as we go through this process here, we are condensing to a liquid. So, what state of matter do we start out in? We're condensing. Very good, gas. Okay, keep that in mind here in just a second. On your chart, here's the problem for methanol. We got 2 values. We have a delta H of vaporization, vape, and a delta H of fusion. Now, think about this. You guys told me condensation is taking a gas going down to a liquid. Okay? Of those 2 processes, that number 1 is not listed, but of those 2 processes, what do you think we're going to use? The vaporization value or the fusion value?
Vaporization.
Okay, we're going to use the vaporization. Now, this is not vaporization here, but I'm going to write this down. So my delta H of vaporization for methanol is listed at 35.2 kilojoules per mole. Now, really important part here is this. Okay, we're not vaporizing anything. We're doing the opposite process, which is condensation. So I'm going to cross out vapor, put condensation. I flipped the process, so what has to happen out in front of that 35.2? Heard it, negative. We have to have a negative because it's the opposite process, all right? So now all we have to do, we have to take this negative 35.2 and we got to put it in our equation here. On top, we're going to have kilojoules. So the negative 35.2 is going to go where? Top or bottom? Top, because 35.2 is tacked on with kilojoules. So don't forget about that negative sign, negative 35.2 kilojoules per 1 mole. Now, if you need your calculators, cool, by all means, but 1 times negative 35.2 kilojoules is just negative 35.2 kilojoules. Now, that problem calculating is pretty easy. what I want you to start thinking about is, all right, phase change, what's happening, and how can I connect it to a given value on the chart? The other thing I want you to keep in mind is this. This value is negative. So is heat released or absorbed? Released, okay? Because heat is released, is it an exothermic or endothermic reaction? Exo, heat exited, right? So getting that mentality as we solve these problems. Any questions? Anybody still need this? Okay, number dos. We put a little bit more complexity. It says use the same table to determine how much heat must be supplied to melt, keyword melt, 4.6 grams of ethanol. So I do this here. I start out and I copy and paste exactly what is given. So I'm going to copy down 4.6 grams of ethanol. And instead of writing down ethanol, I'm going to use the actual formula. So for ethanol there, it's C2H6O. And I'll ask you this. I say time to draw my line. What unit has to cancel diagonal? Grams of that methanol. Very good. And on top, again, if you're not in that middleman moles, which I fast forwarded in problem 1, you got to get to the middleman moles. So mole over gram or gram over mole, you got to use the molar mass. Molar mass of ethanol is what?
46.
Yes. That number, is it going to go on top or bottom? Bottom. So it's going to go on bottom as 46.07 grams per 1 mole. Not quite done yet because we got to worry about that heat business. So I say times, I draw my line, moles of our ethanol is going to cancel out. On top, we want to get to that kJ 4 kilojoules. Okay? Now we have to turn to that chart. So number 1, it says we are melting. We have 2 options. Delta H of FUS, fusion, or delta H of vaporization. What process, fusion or vaporization, is correlated to melting? Fusion, very good. Okay, so that delta H of fusion process for ethanol, delta H FUS, is what?
KJ.
Very good. 4.94 kilojoules per mole. And I'm going to emphasize this. You don't have to do it, but I want to clarify. We had ice, and you put it on the counter, it'd melt. Heat from the room goes into it. We add heat into it. Okay, so just keep that in mind. The 4.94, is it going to go on top or bottom? Good, it's with KJ. On bottom, that's per 1 mole. And so all we got to do is calculate. So we just have to take 4.6 divided by 46.07. I get 0.0998, number keeps going. I multiply that by 4.94. And to 3 decimals, I get 0.493 kilojoules. Now, you don't have to put the plus sign there, but I ask you this. It's positive, so did heat be released?
It was released. Wait, no.
It was gained, which we call absorbed. So exo or endothermic reaction. Yes.
Could we just put 25?
Yeah, I'd probably keep 2 decimals.
Okay.
You'll know rounding when you see it on the test.
Okay.
Yeah, good question. That is the actual formula for ethanol. That is C2H. Oh, yep, I see it now. I should not have put H5. Should have been H6.
That's a,
Yeah. Yeah. Never mind. Good question. Anything else?
number 6.
Number 6. We'll get that one done and then turn you loose. Okay, number 6. It says, hey, what mass of benzene must be burned in order to liberate, keyword here, 1 times 10 to the 4th kilojoules of heat. Then we give our delta H number, okay? Now, first things first, I do not like dealing with scientific notation, so I am going to just change this number here to 10,000 kilojoules. The other thing I'm going to ask you, liberate, right? Liberate, does anyone know what that means? To free, right? To give something away. So if we're giving away, what truly should be our sign? Yes. Okay, so you got to use some vocab here. So we're going to start out with negative 10,000 kilojoules of heat. Our value here, essentially, we're going to work backwards to what we have been doing. So we have negative 10,000 kilojoules. Then we say times, draw our line. What unit cancels diagonal? Kilojoules. If you are not in the middleman moles, you have to get there. We're going to use this value of delta H equals negative 3,268 kilojoules per mole. That negative number there, does it go on top or bottom? So we're going to have negative 3,260 joules per mole. And we got to go one more step because we want the mass. We have times our line. We're going to cancel out moles, specifically moles now of benzene C6H6. And then grams is on top. Molar mass of benzene, I gave it to you on the board. 78 number, 78.11 grams per mole. Does it go on top or bottom?
Top, I mean top.
Yes, top because G for grams. Okay, now before I even calculate this, I have a negative divided by a negative. That turns into a easy. So negative 10,000 divided by negative 3,268. Press enter, I get 3.059. Number keeps going. I multiply that by 78.11. There we are. 239. What would our unit be? Yep, grams of our C6H6. Questions?
239. Nope. Are all the ones on the back just like that?
They're like number 2.
2.
Yeah, just different items or different substances. All right, you need to do problems 3, 4, and 5. Show it to me once you're done, and I'll get you points.